patterns in CosmWasm. So this talk is really geared towards people who are building large-scale applications in CosmWasm. So for people who have maybe learned how to write some basic contracts, and now they want to build a full-fledged app. It includes a bunch of learnings, building Launchpad and building Marketplace. So I thought I'd share some of those design patterns and best practices. All right, so smart contracts, although smart contract programming is pretty new, a lot of the design patterns are actually similar to OO. And there's a lot that we can learn from the last 20, 30 years of knowledge and building large-scale apps. Anyone know this book, Design Patterns by Gang of Four? Yeah, pretty old book, written in 1994. But what it did is it highlighted a lot of design patterns used in software and gave them names. And when you give a design pattern a name, you can talk about it. And that's the great thing about it. So you can say, oh, this looks like a factory, this looks like a singleton, and you can start talking about it. So there's design patterns can roughly fall into 3 different types: creational, structural, and behavioral. And I'll just go over a couple examples of each. So creational patterns, probably the most well-known is factory. A factory pattern basically is a contract that instantiates other contracts. And this is really useful because you can encapsulate all the configuration logic in one place. And you can think of as like a factory with a conveyor belt, and it instantiates other contracts. And you can have consistent instantiation and just kind of much cleaner way to kind of organize your code. And you have reduced risks of errors. And you also get like an index for free, because everything is being instantiated from one contract. So here's a little diagram of how it could be used in practice. This is kind of how we have it in our Launchpad. So you can have some kind of DAO, a multi-sig or governance module that is responsible for instantiating the factory. And then the factory is the one that creates, in this case, it creates minters. And you can have different types of factories that create different types of minters. So for example, if you have like a PFP minter and they all kind of do the same thing, you're going to have a factory that instantiates these. So instead of instantiating each minter by itself, you would have the factory will have an execute message that instantiates. And you can even kind of build it to be kind of generic and take generic parameters. So you can have different types of minters and factories and combine them. All right, singleton pattern. So Uniswap v4 recently launched, and they're like, hey, we're using a singleton contract as if it's something new. It's not something new. It's been around for a long time. A singleton is simply a contract that's meant to be instantiated once. These are very useful for things, contracts that are containers of liquidity and trades. So like a marketplace, a name registry, a DEX. One really interesting thing with CosmWasm is you can have community-owned contracts. So for example, the marketplace in Stargaze is instantiated through governance, and it has no admin. So admins can't do anything, multisigs can't do anything, everything has to go through governance. All right, some structural patterns now. All right, adapter. Adapters are really useful if you have some kind of legacy code and you want to wrap it up in a different interface. So a good example of this, and I don't think this exists yet, and if someone wants to build it, that would be awesome. But I'm sure most of you are familiar with CW20. And now there's also a thing called Token Factory that kind of delegates to the underlying SDK to mint tokens. And this is a little better than having CW20s because the SDK coin types are they're compatible with IBC, and they just like integrate with wallets and all that kind of stuff. So you can build something like a CW20 adapter that has the same interface as CW20, and then you can plug it in everywhere, right? So for example, like Astroport, for example, doesn't works with CW20s, but if you wanted to work with Token Factory, you can just build this adapter and replace all the CW20s with this adapter, and it'll just work, right? So here's like an example of how things are similar, like the Token Factory bindings are at the bottom, and then CW20s in the top, and it's just a few fields that are different, right? So they both could potentially have the same, the same interface. All right, proxy contracts. This is also a very useful pattern. An example is like a whitelist, right? So this is really useful if you have some logic in a contract and you want to do some logic before you execute it. So for example, before you mint, you might want to check a whitelist, right? So that the whitelist can be implemented as a proxy, and then the minting operation actually is just proxied through it if that account is on the whitelist. So this is another thing, it's good to have names for design patterns so you can just be like, oh, hey, that thing needs a proxy. All right, let's talk about some behavioral patterns. Observer, all right. Observer is a really kind of high-level pattern because it could be used across chains, it could be used within contracts. In contracts, you emit events at the end of a function usually, and these can be used, for example, by an indexer to observe the state of these events and track the data. It could even be used across chains. So for example, in Gravity Bridge, which is used to bridge a lot of assets from Ethereum to Cosmos, the way it works is that assets move into a vault contract that's on Ethereum, and then Gravity Bridge has an observer that observes and then remints that value on the Cosmos side. So that's just a very kind of high-level example of a observer pattern. All right. So now we're getting to a few things that are a bit more specific to CosmWasm. Hooks are really nice because they enable other logic to run before or after operations. So another thing that Uniswap just announced that UniV4 has hooks. Us in the CosmWasm world, we've been using this for a long time already. So for example, you can have a smart contract. If you're doing like a sale in a marketplace, you can have a hook that runs before or after. So then you can do some extra logic, right? And people can build all sorts of stuff on top of this. Haven't seen too much yet. I think people are still learning about it, still getting used to it. Here's just some code of kind of how it works. So if you have a marketplace, you can have a hook after the sale, and it can run. Basically, the way it works is that you have a contract that you associate with the hook, and then you have a message that can execute on that contract, and you submit all the data to it. So the hook has some context of everything that's needed for it to execute. Okay, withdrawal pattern. This is also a bit more specific to contracts. This is if it, like anytime you need to send some funds out, it's always better to keep it in the contract and have their account come and claim it instead. The reason for this is that it's easy to have some kind of error where the sending from the bank kind of gets triggered into a loop or something, and you can accidentally like drain the contract. Access restriction pattern. This is basically every time you perform some kind of action on a contract, you want to make sure that the account that is performing it is allowed to do it. So for example, it's very easy to call an action on a contract and accidentally send it some funds, and when it wasn't supposed to get any funds, and then those funds are locked in the contract, and then there's no way to get it out. So for example, this one has 3 kind of checks in the top. Make sure it's non-payable, so it doesn't get any funds. In this case, it checks if the NFT is the owner. It checks if it's tradable, because it could be a non-tradable NFT and so forth. This kind of ties in with the pattern below it, which is guards and fail early. So ideally, you want all these checks and all these guards all the way up top. And then when you do that, the rest of your logic is very linear. So you can have just much cleaner code when you do all the checks up top. Rate limiting, this is really useful, especially for bridges. We had to do this for our name service because we didn't want to launch and then have accounts come and like mint a million names in like a few seconds or something like that, right? So it has some kind of interval. It's not a perfect solution, but at least it prevents a lot of damage. Circuit breaker. All right. This is something that ideally, in an ideal world, you should not need, but we don't live in an ideal world, right? There's chains that halt, there's bridges that go down. So what I kind of like doing is adding a pause function feature into important contracts. And this could be governance gated, it could be multisig gated, but this exists also in traditional finance where there's some kind of circuit breaker. But if you're a purist, you ideally wouldn't have this, but then you might also lose a lot of funds for your users. All right, so just some basic Rust tips. If you're new to Rust, this might be useful. I talked to a lot of devs who are coming from like TypeScript, from Python, from other languages, and they start writing Rust like it's from what they're used to, instead of like really learning it and learning what's nice about Rust. One of them that people might not be used to is adding methods, adding implementations to structs and enums, right? So for those of you who know Rust well, this is very obvious, but what you want to do is try and move most of your logic as methods on your data types itself. So if you do this, then your contract code is much cleaner and much shorter, and everything just kind of like lives on the type. So for example, in this case, this is a struct for an auction. If you just want to get the denom for it, you don't want to write extra lines of code for that. You can just add it as a helper to the auction type. There's another helper there, the minimum Bitcoin. It just makes your contract code a lot cleaner if you do this. Another Rust best practice for control flows to use option and result. So here's just some example code here. In this case, the address is an option. And if you do this the traditional way, you would have to check if there's a sum value. Then you would have to perform some logic over it. And it will probably take 20 lines of code to do what just you can do in like 4 or 5 lines of code here. If you use like map and all these helpers that you get with these option and result types. I really like this diagram. It shows everything that's possible with option. With an option, you have converters, transformers, accessors, and exporters. For example, if you have a data type that's an option, you need to transform it to another type. You can use map. So this just kind of shows everything at a high level. For people that are new to Rust, it's really nice to kind of have this around, especially when you're learning. I also like this a lot. It has option and the result type. You can see all everything that you can do with these types. For example, in CosmWasm, you may have standard errors that you want to convert to a contract error, right? So you'd have the result. You can call map error on it and convert the standard error into a contract error. All right, Rust ownership. This is another kind of gotcha for new people to Rust. I have this kind of silly NFT ownership example for this. So you can think of a variable when you have a new variable, when you call let, it's almost like minting a new NFT and it has an owner. And a variable can only have one owner. And then when it's no longer needed, it gets dropped or gets burnt. And if you create a new variable, for example, in this case, you have let s2 equals s1. That's kind of like an NFT that you had to transfer, right? And then the original owner moved or changed. Borrowing is also something that a lot of new devs have issues with, but just at a very high level, you used the reference kind of notation there to borrow, and there's a mutable version of it as well. And you can only have one copy when you do a mutable borrow. And that's why if you may have seen some of this code in CosmWasm when you have deps, especially if it's inside a loop, you had to do a branch to kind of make a copy of it. All right, just a couple more CosmWasm tips here. I really like ensure. It's just a kind of a short form to check for errors. Really useful at the beginning of a contract when you want to do all your guards. Another tip is to minimize data storage. It's not very apparent sometimes, especially with maps. I've seen a lot of sample code with very long map keys. You have to realize that when things are stored on chain, map keys take up a lot of space because there's a key for every single item of data. So, for example, if your map key is auction and you have 10,000 auctions, you have just that string repeated 10,000 times. So you use really, really short names for your map keys because they're already pre-appended with the contract address. Then you want to get good at purging data when you no longer need it. Also, it's really nice to use Merkle trees, especially if you just want to verify that data exists and you don't have to have all the data in there. For example, for a whitelist, you don't necessarily need to have all the contracts. You just want to know, you don't need to have all the addresses. You just need to know if an address belongs there. Index maps are really nice. These are, you can have secondary indexes on maps. So for example, if you have an auction, you can have a secondary index by the seller, by the end time. And when you have this, you can have like really nice queries. So for example here, you can access the secondary index with .idx. You can prefix it by the seller. And then you can do rage commands to get all the auctions from that particular seller. So there's just a little bit of boilerplate here to set it up. But once you set it up, it's really nice. I also like macros for certain things. For example, if you have like a certain interface that you use over and over again, instead of adding it into every contract, you can create a macro for it. So for example, if you have multiple different types of whitelists and you have a query called includes address, you can make a macro for it, and then you can just add it to all your enums. And this kind of prevents errors. It prevents people from, other developers from like using a different interface. It just makes everything cleaner and more safer. And finally, there's a whole bunch of other best practices, but I really think it's nice to write end-to-end tests in JavaScript. Initially, we used to have our end-to-end tests in Rust, and we even had some in Go. And then what we realized is that then it takes a few weeks or sometimes even months for the front-end team to kind of build out the front end because they don't really have an API for it. So we can actually move a lot faster if the end-to-end tests are written in JavaScript or written in TypeScript, because then you have the interface for the front-end devs. You just kind of get it for free. You can also build CLIs for the front end with certain JavaScript tools. You should be running your chains in Docker or using some other kind of tooling. Cosmology has a thing called Starship that you can use that uses Kubernetes to kind of like set up multiple chains and so forth. Yeah, so that's another thing we learned, is to try and keep that stuff in JavaScript and TypeScript. All right, folks, that's all I had. But there's a whole bunch of other stuff I couldn't fit in here. But if you guys have any other questions about best practices about CosmWasm, you can hit me up, Shane3B.